We've gotten this far with writing our code. Now we want to focus on creating the structure itself for our blockchain. I'm going to create some space down here, and the first thing we're going to do is write type blockchain. Next, inside this, we're going to write transaction pool, along with string and slice. Next, we'll create chain, and inside chain, we want to include the pointer from our block that we previously created. Imagine we have a chain and we're going to be adding on blocks to it. Let's get a little more into the details with this. We'll write func, then bc, then the blockchain from above to create a method. We'll name this as createBlock. To this, we'll pass in nonce int, previous hash, and string. Our return value will be our block pointer. Inside this, we'll have b, new block, and pass in nonce and previous hash. When we create this block inside bc chain, we'll use append and bc chain and we'll add on this block. Then we'll return b. When we do this, we have our blockchain structure, and inside, when we call our create block, we can create this block and include the pointer for that block in our chain. That's the method we created. Once we've gotten this far, we have our blockchain and we want to create a new blockchain function. We'll write func new blockchain and we'll return the pointer for this blockchain. For this as well, we write bc, then new, returning the pointer for the above blockchain structure as new, then bc create block, which we just created down below. In this method, we'll store 0 for nonce and init hash. So what does this all do? In our initial stage, we don't have any previous block. That's why we stored 0 in nonce and our previous hash. We don't have a previous hash, so we stored init hash. We created our very first block and we returned our blockchain structure. And this is the function that we just created. Let's call this from our main function. We're going to delete this section, and this time we want to create blockchain, so we'll call new blockchain. And here as well, we want to print our blockchain as is with fmt println. We'll run our code with this, and when we do, we see an empty slice. This is our return value for transaction pool, and for our chain, we returned a value. This is our new blockchain. It's this section that we just created here. Our printed result isn't visually easy to understand, so here too, let's indicate what data is returned in our return values. Again, let's create a print function. Down below here, we'll add func bc blockchain, then print. Then in our next line, we'll have for I, meaning index, then block. For our range, it'll be bc chain. We want to run the contents of our chain with a loop. Then we'll use fmt printf this time. Then chain %d, then move on to the next line with index. For this block, we've previously created the print method, so this is how we'll write this section. And for now, going down below to our main function, after creating new block, we'll write blockchain print. And now let's run our code. When we do, first we have chain 0. Inside chain 0, we have a block that contains this data. This definitely looks much cleaner and easier to understand than before. Now after this print, we'll add blockchain create block. And for example, we can say nonce is 5 and hash 1. We created the block that's positioned next to our initial block. After this, we'll again add blockchain print. Let's add one more block by copying and pasting the lines for create block. Now let's make our nonce 2 and say hash 2. Let's run our code with this, and when we do, for our first round, we have one block. In our next blockchain create block, chain 0 and chain 1 is returned. Then for our third create block, which is hash 2, we see the results chain 0, 1, and 2. We have init hash, hash 1, and hash 2, so a total of 3 blocks. How our results are presented is not that easy to understand, so let's work on making this look a little better. For example, before chain, we can add %s, and towards the end, we do the same. We also want to add strings and use repeat. So let's add equals 25 times. Then we'll bring I towards the back, and again we'll write strings, repeat, equals, and 25 times. And again at the very end we'll write fmt printf %s and new line. After that we'll again say strings repeat, this time with asterisk 25 times. Let's run our code with this, and this is our results. We're looking at our last set of results, but we see 25 equals symbols here. This is our first block. This is our second block. And last, we have our third block. This is the end of our blockchain, so we have 25 asterisks here. If you format your results like this, I think it's easier to understand. And let's look at this visual to the lower right to go over what we just created. We have 3 blocks. Our first block is this init hash. Then our second block is this. Our third block is this last one. Now that we've created this much, we'll focus next on creating our hash.